Hi, my name is Aina Najla binti Muhammad Nizam and my card metric number is AA192163. For the additional theory, according to the rule of energy and heat transmission, heat or energy always flows from a high potential region to a low potential region. Heat can be transferred from a high potential region to a low potential region using one of three methods. The three heat transfer mechanisms are conduction, convection, and radiation. The heat transmission process that conveys heat between metals are referred to as conduction. Thermal conductivity is a measurement of a material's ability to transmit heat. Thermal conductivity is a property of a substance that connects the heat flow per unit area to the temperature differential across it. The thermal conductivity of a material can be determined by comparing the observed temperature that predicted from a mathematical analysis of heat conduction in a solid body. In most circumstances, we will measure thermal conductivity using one of two methods, which is steady state and non-steady state.
Hi, my name is Ahmad Hafiz bin Ahmad Fiza. My metric number is AA191800 and I will be explaining the objective of the thermal conductivity of solid. The objective is to determine thermal conductivity for an unknown material sample over a range of sample temperatures, thus generating a possible function. Hi, back to me. Now I'm going to present about result and discussion for table 1. First, we have 4 specimens. The first one is nylon. We have the area of the nylon is 0.09 meter square. The thickness of the nylon is 0.009 meter. And for the heat flux is the rate of heat energy that passes through a surface. Uh, the heat flux for nylon is 247 watt. The hot plate is set at 45 degrees Celsius for all specimens, and when cooled down, the cool plate temperature for nylon is 30.9 degrees Celsius. The thermal conductivity is how well a material conducts heat. As for nylon, it is negative 1.752 watt per meter degree Celsius. Thermal resistance, which is a heat property and a measurement of temperature difference by which an object or material resists a heat flow. Basically, it is a reciprocal of thermal conductance. The thermal resistance of nylon is 0.057. Should mention earlier, all the area of the specimens are the same, which is 0.009, sorry, and the thickness of Duratec is 0.003. The heat flux is 315 watt and the cold plate temperature is 31.3 degrees Celsius. The thermal conductivity of Duratec is negative 0.766 watt per meter degree Celsius and the thermal resistance is 0.043 degrees Celsius per watt. For the PVC, the thickness is 0.006 meter. The heat flux is 276 watt and the cold plate temperature is 31.1 degrees Celsius. The thermal conductivity of PVC is negative 1.324 watt per meter degree Celsius and the thermal resistance is 0.05 degrees Celsius over watt. And finally, for PMMA, the thickness is 0.009 meter. The heat flux is 129 watt. The cold plate temperature is 30.2 degrees Celsius. The thermal conductivity is negative 0.872 watt per meter degree Celsius, and the thermal resistance is 0.115 degrees Celsius over watt. Thank you.
Okay, my name is Ahmad Salih bin Abdul Latif. My metric number is AA190177. Okay, next we're going to continue the result and discussion for Table 2 measured and calculated datasheet for multiple layers of specimen. Okay, for the first specimen, nylon and Duratec, the area is 0.09 meter square. The thickness is 0.012 meter. Okay, so the temperature for the hot plate is 45, while the cold plate temperature is 30.2 degrees Celsius. Okay, sum of thermal conductivity is negative 2.518. The heat transfer rate, the QT, is negative 279 279.498. Okay, the overall thermal conductivity, which is the K, is negative 1.259, while the overall thermal resistance is negative 0.053. For the next specimen, nylon and PVC, the area is 0.09 and the thickness is 0.015. Okay, the temperature of hot plate is 45 degrees Celsius, and for the cold plate temperature is 30.5 at 30.4 degrees Celsius. Okay, sum of thermal conductivity is negative 3.076, and the heat transfer rate, the QT, is negative 269.458. For the overall thermal conductivity is negative 1.538, and the overall thermal resistance is negative 0.054. Second last is specimen is nylon and PMMA. Okay, the area is 0.09, same as before, and the thickness is 0.018. The hot plate temperature is 45 degrees Celsius, and the cold plate temperature is 30 degrees Celsius. Okay. Sum of thermal conductivity, okay, negative 2.624, and the heat transfer rate negative 196.80. Okay. For overall thermal conductivity is negative 1.312, and the overall thermal resistance is negative 0.076. And last but not least, the PVC and Duratec. Okay, so the dimension, the area is 0.09 meter squared. The thickness is 0.009 meter, and the hot plate temperature is 45 degrees, while the cold plate temperature is 30.4 degrees Celsius. The sum of thermal conductivity is negative 2.09, and the heat transfer rate is negative 305.14. For the overall thermal conductivity is negative 1.045, and overall thermal resistance is negative 0.048. That's all for me. Thank you.
This is the observation of our experiment. The first thing that we notice is the difference in measurement between four plates PVC, PMMA, nylon, and Duratec. When we test the thickness, we discovered that PMMA and nylon are the same thickness. The hot plate temperature, which is TH, of PVC, PMMA, Duratec, and nylon, all of which are 45.0 degrees Celsius, is the same when we repeat the experiment with just one plate. The temperature of the cold plate, which is TC, is also monitored. The lowest temperature is Duratec, which is followed by PMMA, nylon, and PVC, which has the greatest temperature. In terms of heat flux Q, Duratec has the lowest heat flux throughout the testing, followed by nylon, PVC, and lastly PMMA, which has the highest heat flux. When we repeat the experiment for two plates at the same time, we can find that the combination of PVC, Duratex, nylon plus PMMA, PVC plus nylon, and Duratex plus PMMA are the same at 45.0 degrees Celsius. In addition, when it comes to the cold plate temperature, we can see that nylon plus PMMA has the lowest temperatures, followed by Duratex plus PMMA, PVC plus Duratec, and PVC plus nylon.
Assalamualaikum and a very good evening. My name is Ahmad Muslim bin Ahmad Sharanan and my matrix number is AA190134. For the conclusion and recommendation of experiment thermal conductivities of solid, the result revealed that the type of metal utilized in the cooling pressure has a significant impact on the cooling performance of the materials. This data support the hypothesis. However, the outcome of the experiment will vary based on the condition in which it is conducted, as the cooling of the highest and lower thermal conductive metals in just a few different degrees. And for the recommendation, this experiment could benefit from the addition of a few more metal kinds, particularly nickel and zinc. It might also be done with a larger amount of number and trial a higher heat exposure of the metal. Variation in the testing location's temperature as well as inaccurate readings from the infrared thermometer are some sources of inaccuracy that could lead to defective or incorrect results. Although more testing needs to be done, the result from this experiment is conclusive and supports the premise. That's all from our group for presenting the lab report of thermal conductivity of solid. Thank you and have a nice day.